2007 Form B, Question 1. A sample of solid U3O8 is placed in a rigid 1.5 liter flask. Chlorine gas is added and the flask is heated to 862 Celsius. The equation for the reaction that takes place and the equilibrium constant expression for the reaction are given below. When the system is at equilibrium, the partial pressure of Cl2 gas is 1.007 atmosphere, and the partial pressure of UO2Cl2 is 9.734 times 10 to the negative 4 atmosphere. Question A. Calculate the partial pressure of O2 gas at equilibrium at 862 Celsius. So this is the equation that you are working with, and we're going to carry out an ice. Initial, we have 0 atmosphere for both of the product side, and we add plus 3x and plus x. For 3x because UO2Cl2 has number 3 coefficients, coefficient of the 3, and O2 has 1, so we're going to add 3x and x, and 1.007 is given, and we're going to equal 3x to 9.734 times 10 to the negative 4 atm, which is always also a given. And we have to divide that by 3 to calculate x. And x is actually the partial pressure of O2, since O2 had only the coefficient of 1. So that's the x. So partial pressure of O2 is 3.25 times 10 to the negative 4 atmosphere. Question B. Calculate the value of the equilibrium constant Kp for the system at 862 Celsius. So this question is easy. The value that we just found out from doing ice, we calculated the partial pressure of UO2Cl2, that's the 3x part, and then we're going to cube that, which is 9x cubed. Not just 3x cubed, but 9x cubed, times PO2 over PCl2 cubed. And you have to cube things and sometimes square things in other equation, referencing back to the coefficients of the equation. And then Kp, after you plug everything in, is 2.931 times 10 to the negative 13. Question C. Calculate the Gibbs free energy change, delta G, for the reaction at 862 Celsius. So this question, you have to use the equation delta G equals negative RT ln Kp, and R in this case is gas constant, but it has to be in joules. And temperature T has to be in Kelvin, so you have to add 273 to the Celsius degree temperature that we have. And ln Kp we just calculated in question B. So after you plug everything in, and you have to make sure to convert it back to kilojoules, and you have to divide it by 1000 because 1000 joules equals 1 kilojoules. So the answer is 272 kilojoules per mole. Question D. State whether the entropy change, delta S, for the reaction at 862 Celsius is positive, negative, or 0. Justify your answer. So delta S is a symbol for entropy change, and entropy, so increase in entropy means increase in disorder, and for this equation delta S is positive because on the product side there are 4 gaseous molecules, and there were 3 gaseous molecules we started off, so 3 gas molecules is going to 4 gas molecules, so they're going to be more disorder since there's more gas molecules. Question E. State whether the enthalpy change, delta H, for the reaction at 862 Celsius is positive, negative, or 0. Justify your answer. So in this question, we're going to use the equation go home to supper, and after plugging in the values that we found for delta G and delta S, we can find that delta H is positive. So you just need to plug in the signs to the equation. Question F. After a certain period of time, 1.0 mole of O2 gas is added to the mixture in the flask. Does the mass of U3O8 in the flask increase, decrease, or remain the same? Justify your answer. So the mass of U3O8 solid will increase because, according to the Le Chatelier's principle, the reaction will shift from the right to the left in order to re-establish the equilibrium. So remember your Le Chatelier's principle. If something's added to the reactant side, the reaction is going to proceed to the right side, which is the product. Thank you.